Hello, e-learning people. We have a little bit to do today. So last class we talked about simplifying rational expressions, which are fractions, and multiplying and dividing. And today we are talking about adding and subtracting rational expressions, essentially adding and subtracting fractions. Now when you hear about adding and subtracting fractions, hopefully in your mind you think back and remember common denominators, because that's going to be the big idea today. Is if I look at example 1 here and I want to add these fractions together, I need common denominators in order to do that. So if I look at these, I can't add these together right away because I don't have common denominators. So that's going to be our objective, is we need to get common denominators first, and then we can add and subtract the fractions together. Okay, so let's talk about how we do this. If you have a denominator that needs to be factored, you go ahead and factor it first. So I look here and I have an x minus 1, an x, and an x squared plus 1. Out of these three, the x squared plus 1 can factor. And so I'm actually going to go ahead and do that. So I'm going to factor, and I'm going to put x plus 1, x minus 1. Okay. Now, I look at my denominators and think about what they all need to have. So if I notice, this has an x minus 1, this has an x, and then this has an x plus 1 and an x minus 1. Okay, so that means the three things I need to focus on, look at the three things that are different. I have an x minus 1 here, I have an x here, I have an x plus 1, and an x minus 1. Okay, so I need common denominators. What that means is this first fraction has an x minus 1 already, but it needs an x and it needs an x plus 1. So what I do, I multiply the first fraction by x plus 1 and x, the numerator and denominator, by x and x plus 1. And I do the same thing in the denominator, x, x plus 1. So notice that gives me all three pieces in the denominator that I need, an x plus 1, and x minus 1. Now I go to the second denominator. It already has an x. For some reason this is not erasing. What the heck? Well, I don't know. It already has an x, but it needs to have an x plus 1 and an x minus 1. So I'm going to multiply the numerator and denominator by x plus 1, x minus 1. Same thing down here. X plus 1, x minus 1. The last set only needs an x. So the last set needs to be multiplied by an x on top and an x on bottom. Now I'm going to stop and look at what we did. Look at all three denominators. They all have an x plus 1, and an x minus 1. So they all have the same denominator. What that means is I can actually combine all of these fractions now. But the first thing I'm going to do is simplify all the numerators first. So I'm going to do this in my next line. I'm going to multiply this stuff together. Essentially, I need to multiply this 3 and this x and distribute it inside the parentheses. So think of it as the 3 being out here in front instead of being here. So I'm distributing 3x. So I get 3x squared and then plus 3 in the first numerator. In the second numerator, so I put minus, I'm going to put parentheses, and I'm subtracting. Now over here, understand that this that I'm circling right now, this x plus 1, x minus 1, that is the same as x squared minus 1. So essentially I'm multiplying 2 to x squared minus 1. So it would be 2x squared minus 2. That's the second numerator. And the third one, plus, I need to distribute this x and get x squared plus 3x. Okay, so I got common denominators for all these things. Now, all of that is over the new denominator. You don't need to multiply it together. Just leave it as x, x plus 1, x minus 1. But now I need to simplify in the numerator. So I look here and I have a 3x squared minus 2x squared plus 1x squared. So I have 3x squared minus 2x squared, that's 1x squared, plus 1x squared is 2x squared. So I have 2x squared. Let's see, any x's? Yeah, I have a 3x, so plus 3x. and then I have a 3. I have a plus 2, because this minus sign will go to the negative 2, so 3 plus 2 is 5. All over x, x plus 1, x minus 1. So that's simplifying. I was able to add and subtract all these fractions together. In the numerator here, I would look to factor if it did. It doesn't. And the way I know that it doesn't is I looked ahead. If I do the AC method to try to factor it, I get 10. And nothing multiplies to be 10 and adds up to 3. So that tells me that that doesn't factor. So I would try to see if it factored and canceled stuff out, but it doesn't. And there's my final answer. It looks messy, but after you try a few, it's not so bad. So look at example 2. When you are adding and subtracting, you cannot add and subtract first. You have to get common denominators. Well, to do that, I look at my denominators and factor if need be. So this bottom one factors into x minus 4, x plus 2. Okay. Over here, I need to find what multiplies to negative 20 and adds up to 1. So x plus 5, x minus 4. Okay, so now I have to get these denominators to be the same. Well, if you notice, they both have x plus 4s already. So I don't need to worry about the x plus 4. But the first fraction needs this x plus 5, and the second fraction needs this x plus 2. And here's how we make that happen. In the first fraction, I'm going to multiply numerator and denominator by x plus 5. In the second fraction, I need it to have an x plus 2, so I multiply it by x plus 2, x plus 2. So now look at both denominators. They both have factors of x plus 5, x minus 4, and x plus 2. They're the same. So now that means I can combine these. But before I combine them, I have to do this multiplication up here. A lot of people forget this step. I need to multiply x plus 5 and x minus 5 together. So that's going to, I could FOIL that, but it's going to turn out to be x squared minus 25. The middle terms will cancel. Minus, I bring this minus sign down here. And then over here, I'm going to put in parentheses. When you're subtracting the second numerator, you have to put the entire thing in parentheses. And this would be 5x plus 10. Because I'm subtracting that whole second numerator. And now that's going to be x squared. And then this becomes negative 5x. And I have negative 25, and this will be minus 10. That minus sign goes with the 10, so negative 35. All over. And then I have that denominator that I need to put. X plus 5, x minus 4, x plus 2. I would try to factor the numerator, so I try to find what multiplies to negative 35 and adds up to negative 5, but nothing does because your only possibilities are 7 and 5. That's not going to work, so that means that's your final answer. So you need common denominators, and then combine them. Okay. Last one here. I would take a minute and pause the video and try to do this one. See how well you're understanding this. So I'd pause it, try it, and then after you finish, push play again, and then I'll walk through it and see if you're doing it correctly. So take a second and pause it and go ahead and try it. Okay, so hopefully you tried it. And first you factor both denominators. So that would be 2x minus 6. This would be x minus 6, x plus 2. Okay, so I look at what they need to have. They both have x minus 6. Good. The first one needs an x plus 2. I know it has a 2 here, but we're talking about factors. So I need it to have a whole factor of x plus 2. So I'm going to multiply by x plus 2, top and bottom. The second fraction needs a 2 in it. So times 2 times 2. So they have the same exact denominator now, the same 3 factors. Now I simplify the numerators. I get 5x plus 10. A lot of people forget this multiplication step. 5x plus 10 minus, and then over here I get 40. Over, and then I'm just going to put all 3 factors, x minus 6, x plus 2, and 2. I can simplify in the numerator. I get 5x minus 30 over 2x minus 6, x plus 2. And I said on the other ones, you try to factor if you can. And this is one where you can factor. This 5x minus 30, I could take a 5 out, and I get x minus 6. And this is nice because now those x minus 6's go away. And I get 5 in the numerator, and then 2 times x plus 2 in the denominator. So hopefully you tried that out and got this. And there you go. So that is how you add and subtract fractions. You identify the common denominator, and you try to make all the fractions have them. And then there's just some manipulation you need to do for the numerators. Okay. So now we got a few other different types of problems to solve. 4 and 5 look like they're going to be pretty scary. These are called complex fractions. And they're really not too bad. These are called complex fractions because you have fractions mixed within fractions. Whole lot of fractions. Fractions, fractions, fractions. Okay. So the way we attack these, pretty straightforward. Only focus on the numerator to begin with. Only focus up here and somehow combine those two things together. Then focus down here and combine these two fractions together. So essentially you're adding the two fractions on top. I know it's a 1, but it's still a fraction. You can look at it as a fraction. Combine the fractions on top, combine the fractions on bottom, and then we'll talk about what to do after that. So we're going to use what we just talked about. We need common denominators to combine these fractions. Okay, so in the numerator, this has an x, this is over 1. To get common denominators, I need to multiply the first fraction by x over x. And so that's going to be, I'm going to simplify this over here. In the numerators, I'm going to have x minus 2, because I get an x from here, and then minus 2, over, well now they both have denominators of x, so I just put the same denominator that they have. So take a second to understand where this came from. I got common denominators, combined them, notice the x just stays the same. Okay, over, now I need to do the same thing in the denominator. I need common denominators. So this first fraction down here needs a factor of an x, so I'm going to multiply by x over x. And the second one needs a factor of x minus 1. That gets those to be the same. So I'm going to do some manipulation down here below. So that's going to be 5x. And then plus, I'm going to distribute the 4. 4x minus 4. And then that's going to become 9x minus 4. So over here, down below, I'm going to put 9x minus 4 over, and now understand that they have an x and an x minus 1. So I'm going to stop and take a look and see if you understand where this came from. I combined the fractions on top to get here. I combined the fractions on bottom to get here. And now here's the thing. We have a fraction divided by a fraction. The whole goal of combining them was we have a fraction divided by a fraction. Well, in math, we never divide by fractions. Never. You always multiply by the reciprocal. So what we do, we take the first fraction, x minus 2 over x, and instead of dividing by this fraction right here, we are going to multiply by the reciprocal of that blue circle. So we'll have x minus 1 in the numerator, 9x minus 4. Make sure instead of just writing down what I'm writing, you're listening and trying to follow step by step. So instead of dividing fractions, we multiplied by the reciprocal. Now it's like last class where we look to cancel things out and factor. Well, these x's go away. And I can't really do anything else, so I'm just going to put this stuff next to each other. So I have x minus 2 and x minus 1 in the numerator, and then I have 9x minus 4 in the denominator. That's how you deal with complex fractions. You combine the numerator, combine the denominator, and then multiply by the reciprocal. So again, I might take a moment, if I were you, and see if you could do example 5. So I would pause the video, try it on your own. I mean, that's how you're going to learn your math. You do it on your own, you make your mistakes, and you find out where, rather than just writing what I'm saying. So pause it and try it. Okay. So in the numerator, we want to combine these. Right now, that's 3 over 1. So I need to multiply the second thing by x over x. And so I get 2 minus 3x over over x. That's what I have in the first numerator. Divided by, and now down here, I need to multiply by x minus 1 over x minus 1. And I'm going to do this work off to the side, so I'm going to multiply those numerators together, and I get x minus 1, and then minus 1 over x minus 1, and that becomes x minus 2. So I'm going to write this over here, x minus 2 over x minus 1. Okay, so I combined those fractions. Now, instead of dividing fractions, we multiply by the reciprocal. So I'm going to do 2 minus 3x over x times the reciprocal of this bottom fraction, x minus 1 over x minus 2. Nothing factors, nothing cancels. That means my final answer is just multiplying these things together. So I would put 2 minus 3x next to x minus 1 over x minus 2. And there you have it. All right.